right, guys. So we are going to walk through some of the math problems from the Chapter 2 practice test. So we're going to get started with number 3. So number 3, we are given a position versus time graph. And first, we want to find the average velocity of the object from 0 to 6 seconds. Okay. So here we want to keep in mind that our average velocity, we know as displacement over time. Okay, so how far our initial and ending positions from one another divided by how long we took to get to that final position. And if we think of that in terms of graph words, this is what we're going to define as our slope. So to find the average velocity from 0 to 6 seconds, we really want to find our slope here. So we'll look at where our position ends. So we can see that we end at 6:20 and where our position began. So we can see at time 0, we had a position of 50. So we want to start off by finding our slope. So we take our two y values, find the difference, and then divide that by the difference in our two x values. And here we should find that our displacement, or the difference in those two y values, is negative 30 divided by our 6 seconds. That means our average velocity in this same time frame is negative 5 meters. So then when we want to write a mathematical expression, this we're looking for the equation of our line. And we know we use y equals mx plus b. So here our y is our position. That's equal to our slope, which we found to be negative 5 meters per second, times our x variable of time, plus our starting position of 50 meters. Okay, so that's what we should have had for our mathematical expression of our object's motion here. All right, so looking at number 4, we're given a velocity time graph in this one, and we want to first describe the motion of our object. So we're going to basically look at it in separate time intervals. So our first time interval is going to be 0 to 2 seconds. So we can see from 0 to 2 seconds, our object is moving in the positive direction because we have a positive velocity. Okay, and that velocity itself is going to be 2 meters per second. Okay, because we can just look and see what that horizontal value is on our velocity time graph. From 2 to 3 seconds, however, we're below the x-axis, so we have a negative velocity. So that tells us we're moving in the negative direction. Okay. And now we're moving in the negative direction at negative 3 meters per second. Okay, so we're moving backwards quickly. From 3 to 5 then, that is our last time frame. Here again, we're below the x-axis. So that tells us we're traveling backwards. And here, that velocity is going to be negative 2 meters per second. So from 3 to 5 seconds, we're still moving backwards because we're below the x-axis, but we're moving at a slower rate of negative 2 meters per second. Okay. For B, we want to draw a corresponding position versus time graph. And it tells us we may assume the object starts from the 0. That's how the object starts at 0. Oops. In order to do this, we need to figure out how far our object travels in each time interval. So our first interval was 0 to 2 seconds. And there we saw 2 seconds is moving at a rate of 2 meters per second. So that tells us it traveled a displacement of 4 meters. So essentially what I can do is I can find how far my object travels the displacement by finding the area of my velocity time graph. Because I took my base of 2 times my height of 2. And that told me my object traveled 4 meters. So if we started at 0, after 2 seconds, our new position is going to be 4 meters ahead of that. So it'll be at a position of 4 meters. From 2 to 3, we'll do the same idea. So here, we're moving for 1 second at a rate of negative 3 meters per second. That tells us I traveled negative 3 meters. So again, we take my height of negative 3 times my base of 1, and we'll find that our object travels 3 meters backwards. So at 3 seconds, if we were originally at 4 meters, and we travel 3 meters backwards, our new position will be at 1 meter. And for that last time frame here, 3 to 5 seconds, moving for 2 seconds at a rate of -2 meters per second. So -2 meters per second for 2 seconds tells me I travel -4 meters here. So again, I'm taking my height of -2 times my base of 2 seconds. Okay. So if at 3 seconds I was at a position of 1, at 5 seconds, I'm going to be 4 meters behind that. So that means my new position at 5 seconds would be -3 because it's 4 meters behind where I was at 3 seconds. Okay. So we're looking at our displacements to tell us what our position versus time graph should look like. All right. So then for C, we want to see how far the object travels in 0 to 2 seconds. We already found this. Okay. We said if we're moving for 2 seconds at 2 meters per second, that told us we're traveling 4 meters. And that's what we found when we did our area of our velocity time graph. Okay. When we want to find our overall displacement from 0 to 5 seconds, there's kind of 2 ways we could do this. Our first way is looking at our velocity time graph. We can add up all of our individual areas. So we would take our first displacement of 3 first displacement of 4 minus the 3 meters we traveled in 2 to 3 seconds minus the 4 meters we traveled in 3 to 5. And there we should find that our displacement is going to be -3 meters. The second way we can do that is using our position versus time graph. And here we can just compare our final and our starting position. So here we ended at a position of -3 and we started at a position of 0. So that means we traveled 3 meters backwards from where we started. Again, our average displacement then would be -3 meters. All right. So then E, we are going to use that displacement calculating our average velocity. Because I know velocity is equal displacement over time. Okay. And we found in letter D that our displacement is -3 meters over time interval of 5 seconds. So that means my average velocity then would be -0.6 meters per second. What that tells us is that each second we are getting -0.6 meters closer to the ending position. Okay. So each second we travel, we're getting -0.6 meters closer to where we end up. That is different than our average speed. Average speed looks at the rate we're traveling in any direction. So we know speed is distance over time. So to here find our distance, we're again going to add up our individual displacements, but we don't care about the sign, so we are going to make them all positive. Because distance and speed are scalars, we need to change the direction. And that's still over 5 seconds. This tells us that we're moving in any direction at 2.2 meters per second. Not necessarily towards the ending point, but in any direction. This is going to be an example of a two-body problem. So, a police officer stopped at a sign. All of a sudden, a speedy pedestrian, Barry Allen, passes her from behind, going 25 meters per second. The police officer turns on her flashing light, calls for backup, and 3 seconds after being passed, she pursues at 30 meters per second. So we want to make a position versus time graph for the motion of this case. And we want to find when and where the officer will catch up to Barry Allen. So before we make our quantitative position versus time graph, it's not a bad idea to kind of just sketch the general motion. Okay, because we don't know the exact position and time they're going to meet at, but we can kind of sketch a general idea of what's going on here. Okay, so when we do these, we kind of need to ask ourselves 3 questions. First, do they start at the same position? Okay, so do the Barry Allen and the police officer start at the same position? The second question we need to ask ourselves is, do they start at the same time? And the third and final question is, do they move in the same direction? So these three questions will kind of guide us what our position versus time graph should look like. So if we look at this one, we can see that Barry Allen passes the police officer. So we're going to consider them starting at the same position. Okay? Because when we first look at our police officer and Barry Allen, they're at the same spot. They're passing one another. Okay? So to make it easier on ourselves, we're going to have them both start at the origin. So both start at a position of 0. However, we can see that they do not start at the same time. We can see that the police officer starts 3 seconds later. So if we have Barry starting at a time and position of 0, that means our police officer is going to have to start 3 seconds later. And since they're moving in the same direction, because she is chasing him, they're both going to have a positive slope. So this kind of gives us a general graph of what our motion should look like. Now that we have our general idea, we can start writing equations for Barry Allen and the police officer. So when we look at Barry, for his position, we can see that his slope is going to be 25 meters per second because our slope is equal to our velocity and our x variable is time. So we have 25 meters per second times time. And since Barry starts at the origin, we have no y-intercept there. Looking at the police officer then, here, her velocity is 30 meters per second, so that'll be our slope. Again, since they're moving in the same direction, they're both going to have a positive slope. However, we can't just multiply her by time. We need to look and see how long she's moving. And we can see that the police officer is moving for 3 seconds less than Barry. So instead of just multiplying it by time, we would do time minus 3 because she's moving 3 seconds less. Okay? Always subtract the delay. Okay? To show that they're moving for less time. So always subtract the delay. And then since she too starts at a position of 0, she's not going to have a y-intercept either. Okay. All right. From here, once we have our two positions, we want to see at what time they will meet at or at what time their positions are the same. So we can set these two equations equal to 100. When you're solving, be sure to distribute the 30 to both the t and the negative 3. So do 30 times t and 30 times negative 3. Then we'll want to get our t's all over to one side. So subtract 30. So that's negative 5t is equal to negative 90. And we'll find that our police officer and Barry meet after a time of 18 seconds. So she catches up to him after 18 seconds. We then want to find what position they meet at. So we can plug this 18 seconds into either one of our equations. It does not matter since their positions will be the same. So I always like to just choose the easy one. So we plug it into Barry's equation. We'll do 25 meters per second times 18 seconds, and we'll find that they meet at a position of 450 meters. All right. So we know they'll meet after 18 seconds at a position of 450. So here we can go ahead and make our position time graph because now we know the exact time and position our police officer and Barry Allen will meet at. Okay. So make sure you guys scale your axes so that you had equal numbers in between your positions and your times. All right, and we'll put position on our Y as usual and time on our X. Okay, so for each person, we'll have 2 points, the position that they start at. So Barry starts at 0, 0, and the position that they meet at. So that would be 18, 450. We're going to do the same thing for the police officer. So she is going to start at 3, 0. And again, they'll meet at 18,450. So we'll get a position versus time graph that looks something like this, where police officer is the line in blue and Barry is the line in pink. Perfect. Okay, so just trying to remember when you're doing those two body problems, ask yourselves these 3 questions when doing your sketch and setting up those equations, and then wait to do that labeled quantitative graph until the end, because then we'll know where they meet. All right, so looking at these ones, we want to see where we have 0 velocity. So if we're given a position versus time, we know that our velocity is equal to our speed. So here we want to see where we'd have a slope of 0 or have a horizontal line, and that's going to be B. Okay, B is a horizontal line, so it has a slope of 0, it has a velocity of 0. For 7, we want to see a negative position. So since this is a position versus time graph, if we have a negative position, we're just going to be below the x-axis. Okay, so we can see A is below the x-axis, B is below the x-axis, and C is below the x-axis for part of our time. Okay, so for this one, we can actually select letter E, because A, B, and C sometime below the x-axis. So at some point in time, they all have a position of 0. Okay. For 8, we want to see where we have a positive velocity. Again, our velocity is equal to slope. We want to see where we have a positive slope. And that's going to end up being A and C, because they both are sloping upwards. We're both moving in the positive direction.